Hi everyone, my name is Konstantin and I'm a member of the machine learning team here at Neural Magic. In this video, I'll be walking you through how to accelerate your NLP inference pipeline and deploy on CPU with the power of compound sparsification and the DeepSparse engine. In NLP, we can find a variety of performance-critical use cases. Whether you're crawling the web and performing sentiment analysis to pick up on trends in the industry, where you might have throughput constraints, or developing a question and answering bot to quickly serve your users, where minimal latency is of the utmost importance, or using a token classification system to build an automatic document parsing system on an edge device. And as we know with edge, size is almost always a constraint. In all of these use cases, Neural Magic has you covered. In this video, we cover all of these use cases and are actively working on adding more. Let's take a look at how we can use SparseML and DeepSparse to deploy your own sparsified model. For this video, we'll be using a text classification model. Let's set up our environment. Once we've created a fresh virtual environment, we'll install the DeepSparse and SparseML libraries with a single pip command. Remember, the SparseML library powers a sparsification pipeline, allowing us to turn existing dense networks into sparse ones, while DeepSparse allows us to execute our sparse models at top speed. Now, let's check out the sparse view and pick a model that will suit our needs. Let's choose this 80% pruned and quantized DistillBird model. Remember, this means that 80% of the network's connections have been trimmed away and a quantization lowered the precision of the model to int 8. The perfect recipe for cutting-edge execution with DeepSparse. Now let's benchmark it on CPU to see just how fast it is. First, we'll benchmark the model with the Onyx Runtime engine to set a baseline. Now, let's compare that to the DeepSparse engine. Great, I think this will do. The model we have now is ready for deployment, but what if we have a custom dataset we want the model to learn? This is where sparse transfer learning with SparseML comes into play. Let's transfer this model on the SST2 dataset, a popular dataset designed for sentiment analysis. With this one command, we can use our sparse model together with a sparsification recipe to transfer learn the model on our new dataset. Let's try it. Okay, this will take a few hours, so let's just jump to the end. That's better than the days it would take if we trained from scratch. Okay, now we're ready to deploy our model. Let's get it running with the DeepSparse Python API. First, we import pipeline. This is the entry point to the engine that takes care of data pre- and post-processing, so we don't have to worry about it. Now, we can create a pipeline that will handle sentiment analysis input. Let's draft up some example input and pass it to the model. Looks like our model picked up on the positivity. This model and many like it that are available on the Sparsity can be deployed in a variety of environments. I'll also leave a link to our dedicated Sparsity video down in the description. Make sure to check out our docs for more examples of NLP deployments covering all supported use cases. There you have it! We've learned how to harness the power of Sparsity to deploy our models without the need of a GPU. To learn more about the amazing technology we've built here, make sure to check out all of the other videos by my colleagues and feel free to join us in the community's Slack. Thanks for joining me on the sparsification journey. One more thing. Let's see how Twitter feels about Sparsity. I guess they approve.